Township Canada is a web application that allows users to geocode Canadian legal land descriptions and get turn-by-turn navigation between 2 points of interest. And legal land descriptions are based on survey grid networks that divide the country into equal-sized parcels of land. And many industries, including oil and gas and agriculture, use legal land descriptions to identify their assets, for example, wells, facilities, and land parcels. Township Canada provides two main pieces of functionality. One is search, which empowers users to find legal land descriptions, geographical coordinates, and places in Canada. It also provides real-time recommendations as users type in their search term and allows them to convert legal land descriptions to geographical coordinates and vice versa. The second is batch conversion, which empowers users to geocode and reverse geocode many records at once. The search and batch conversion APIs are the heart of the application. In fact, those APIs are the building blocks of townshipcanada.com and developer.townshipcanada.com. As the number of supported provinces and their survey grid systems grew over time, the performance of the search and batch conversion APIs has been one of the main challenges that I've had to deal with since I started this project. They are resource-intensive operations that run on the database side. In Township Canada, the search and batch conversion functions work on around 25 million records and 36 gig of spatial data. So for this hackathon, my goal was to evaluate the performance of the Graviton powered RDS Postgres and Lambda functions behind the search and batch conversion APIs and modernize the stack if there was a significant improvement. So before I get into the results of my evaluation, I want to show how it works. So if you log in, you would see a map interface. It has a search box that you can use to search for different location types that you're interested in, whether it's legal land location or geographical coordinates or places, addresses, postal codes, and whatnot. And you can also use the batch conversion tool. If you have many records, you can just copy and paste them here, do convert, and display them on the map. You can download them, you can add them to your profile, and so on and so forth. So the search and batch conversion APIs are really simple APIs. They are REST APIs built with the serverless framework hosted on Amazon AWS. So that means that they are a mix of AWS API Gateway and Lambda function. I've built them using Node.js and Express, and they're backed by an RDS Postgres. So to evaluate the performance of Graviton-powered instances versus their x86-based counterparts, I created two different RDS Postgres instances, one on Graviton-powered, micro Graviton T4G, the other one on non-Graviton or x86 T3 micro. And they have the same hardware spec. They have two CPUs, 1 gig of RAM, same storage, SSD, and they run the same software, Postgres 12.7 and PostGIS 2.5.2. And I did the same thing for the Lambda functions behind the APIs. I deployed two different versions of the Lambda functions using two different architectures, x86_64 and ARM64. And I used Apache JMeter to send geocoding and reverse geocoding HTTP requests to those APIs and measure the response time. And I repeated the experiment 30 times to get representative results. And the results show that the Graviton-based architecture provides between 15% and 64% performance improvement over the x86-based architecture when doing geocoding requests and reverse geocoding requests on the search and batch conversion APIs. So you can see the full report on the performance evaluation results and on the submission and the Google Doc basically document. So since the performance gain was huge, I migrated the stack behind townshipcanada.com and developer.townshipcanada.com to Graviton powered stack, which means the Postgres, the RDS Postgres behind the APIs run on a Graviton powered RDS, and the Lambda functions run on ARM64 as well.